Welcome back to our special series on electromagnetism. In this segment, we'll be discussing electromagnetic interference, or EMI, and its various effects. Joining Joanna is our expert, Ruth, who will provide insights into how EMI impacts electronic devices and human sensations.
Ruth, let's start with an overview of electromagnetic interference. What is EMI, and how does it affect electronic devices?
Electromagnetic interference, or EMI, occurs when an electromagnetic field disrupts the normal operation of electronic devices. This can happen when electromagnetic signals from different sources overlap and interfere with each other. EMI can cause malfunctions, data corruption, and even permanent damage to electronic components. Common sources of EMI include power lines, radio transmitters, cell phones, and household appliances like microwave ovens and Wi-Fi routers.
That sounds concerning. Can you give us some examples of common sources of EMI and how they affect electronic devices?
Certainly. Power lines and electrical equipment can generate electromagnetic fields that interfere with nearby electronic devices, causing issues like signal degradation or data loss. Radio transmitters, such as those used for broadcasting and communication, can also cause EMI, particularly if they are operating at high power levels. Household appliances, especially those with motors or switching power supplies, can create EMI that affects other devices in the home. For example, a microwave oven can interfere with Wi-Fi signals, and a faulty power supply can cause static on a radio.
Interesting. Now let's discuss the potential impacts of EMI on human sensations and health. Can equipment designed for EMI affect humans?
Yes, equipment designed for electromagnetic interference can potentially affect human sensations under certain conditions. Some people report experiencing symptoms such as headaches, fatigue, and stress when exposed to electromagnetic fields, a condition known as electromagnetic hypersensitivity, EHS. Although scientific evidence regarding EHS is inconclusive, it highlights the potential for EMFs to affect human well-being. High-intensity EMFs can induce currents in the body, leading to sensations like tingling or muscle contractions. These effects are generally observed at field strengths much higher than those typically encountered in everyday environments.
What about thermal effects and nerve stimulation?
High-power EMFs can cause heating of tissues, which is the principle behind microwave ovens. In humans, high-power EMFs can lead to thermal effects, causing sensations of warmth or even burns if the exposure is intense enough. Certain frequencies and intensities of EMFs can stimulate nerves and muscles, similar to how transcranial magnetic stimulation, TMS, uses magnetic fields to stimulate nerve cells in the brain for therapeutic purposes. This demonstrates that EMFs can indeed affect the nervous system.
Are there any regulatory limits to protect public health from these effects?
Yes, regulatory bodies like the International Commission on Non-Ionizing Radiation Protection, ICNIRP, and the Federal Communications Commission, FCC, set exposure limits for EMFs to prevent harmful thermal and non-thermal effects on the human body. These limits ensure that everyday exposure to EMFs from common devices like cell phones, Wi-Fi routers, and household appliances is generally safe.
Thank you, Ruth, for explaining the impacts of electromagnetic interference on both electronic devices and human health. In our next segment, we'll discuss advanced electromagnetic concepts, including beamforming and phased arrays, and their applications in telecommunications and defense. Stay tuned as we continue to explore the fascinating world of electromagnetism.